The most difficult part of this chapter is the last section, transformations. So we're going to save that for Wednesday. We're going to do just one entire day. All we're going to do today, we're going to do sections 2.4 and 2.5. Math 13, 14 video. Wow, almost at the end of September. The composition of functions. And then the next one is we're going to get odd, even functions. Through symmetry. All right. If you, in the real world, that you'll see a lot of times in mathematics that one function is needed, the answer of one function is needed to be an input to another function. For example, think your taxes. The amount of taxes you pay depends on what? How much you worked, how much minus what you have taken out. If you have any retirement or investments with that, that's taken out pre-taxes, all this stuff, your Medicare and stuff. Then you get taxed on your gross and your net incomes. So there you have one function feeding into another. That's what we call composition or composite functions. A function within a function. Typically, if you ever talk to anybody else who's taken algebra and you talk about composite functions, you'll always refer it to the Fog and Goth method. These are not words, Fog and Goth. It's actually the math symbol, but we just call it Fog Goth. It sounds really bad. Let's say we had two functions. Say 2x plus 3 is function f, and then function g of x is square root of x. A composite function it's actually read f of g of x. So what does that mean? F of g of x. So whenever you see this, this means of. So remember, what does this mean? How would we read that? How do you read that? Yeah, f of x. So whatever's after the word of is your input. F of g, so that means g is the input of f. That's what that means. So in our f function, anywhere we see an x, replace it with g of x. This is our f function. Anywhere C and X, because it's inside the parentheses. Whatever is inside the parentheses takes the place of X. What is G of X? G of X is square root of X. So there you have f of G. Work that one out with the same functions you have. Goth. So the way this is read, it's G of f of X. So it's G of f of X. But basically you're working out, coming back in. So this X belongs to this F. That's f of X. So this whole thing goes inside G. So in our G function, anywhere is C and X, replace it with f of X. So anywhere C and X, put f of X. And f of X equals 2x plus 3. Let's look at another one. I'll go with your. Let's do another one, a larger one with fractions. F of X. Well, let me put another easy one in there. And you have the Fog and the Goth. if you make this connection here, now all this means is this. Whatever you see in G, whatever's in here goes in here. So it's 3 times 1 over x, or 3 over x. And since f is inside the G, take the f and put it in place of x. 1 over 3x. Those are your answers. Make sense? All it is plugging one function into another. And remember, we did the algebra of functions. We did f plus g of x. We could have spread that out like this: f of x plus g of x. We could do the same thing with composite functions. F of x equals 3x plus 5. G of x equals 2 minus 3x. Because I can ask you, instead of x, I can give you a specific value in there. And you can either work at putting the functions together first, then put the x in there, or find the x's first and then use those. So this one is f of g of 2. So we first have to find g of 2. So g of 2 is 2 minus 3 times 2. 2 minus 6 is negative 4. So this number goes in place of that function. So we find the value of g of x first, put that inside there. So now we go anywhere we see in the f function, anywhere we see an x, put a negative 4. So we have 3 times negative 4 plus 5. 3 times negative 4 is negative 12 plus 5. 12 is bigger than 5. Answer is negative 7. Does everybody follow how I did that? So go ahead and do the other one, g of f of negative 3. So that's G of fx, which is G of f of negative 3 f of negative 3 negative 9 plus 5, which is negative 4. Let's first find the f of negative 3. So f of negative 3 is negative 4. And so in the g function, anywhere c and x, put a negative 4. So it's 2 minus 3 times negative 4. Negative is a positive. 3 times 4 is 12. We didn't hear you. All right. So the hardest part about this is remembering what goes where. Let's hope that works. Want to try another one or move on? One more? Okay. Try one more. F of x equals 2x squared. I'll leave it there. 2x squared. And g of x equals the square root of x. So find f of g of 2, and then g of f of negative 1. Make it negative 2. Here's what that's what I'll show you this one here. So this fog method, you read right to left in this one. So you first take g of 2. So whatever g of 2 is, so square root of 2, whatever that is, goes inside the other function. So we have to first find this value, then plug that into the function. Now here, go to the f function, anywhere c and x, put a square root of 2. So 2 square root of 2 squared. What is square root of 2 squared? Remember, how would you solve for x here? If I had square root of x equals 5, how would you solve for x? How would you get rid of the square root? Square both sides. Because the square and the square root cancel. So x equals 25. So the square and the square root cancel. That just leaves 2 inside there. 2 times 2 is 4. So there's the first answer. Now, likewise, the second one. We have to first find out what this is. So f of -2. Anywhere we see an x, we put a -2 in its place. -2 squared is +4. -2 times -2. 2 times 4 is 8. So this 8 goes inside there. Because this whole thing is the f of -2. So now we have g of 8. So here's g. So we go to square root of 8. Is anybody still kind of lost? Still okay. But we're going to do the homework problems in a minute also. So I'm just giving you, this is what it means. And if we need to, we'll go further deeper into it. 8 is made up of 4 times 2. 4 is 2 times 2. So the square root of 8, because it's a square root, I have 2 of a kind. So that comes out. Anything left stays in the square root. So that one stays there. These 2 come out. That last one stays in. So that's composite functions. Composite functions are functions within functions. What do you think the opposite direction is? Decomposition of functions. This method is used mostly in calculus courses where you have to know what a function is made up of, the smaller pieces. Let's say h of x is equal to 2x plus 3 squared. The decomposition is we have to try to find 2 functions that make that what it is. So can you guess which 2 functions put together make that up? Let's say that's f of x, 2x plus 3. If that's f of x, what is g of x? So h of x is actually g of f of x. So you look for a basic, a small equation. That's one of the functions. And then the second, where is that one? If I replace this whole thing with x, I'd have another function. So this function goes inside there, and I have the h of x. So that's how you look to try to decompose a function. This gets a little more difficult. But what if I gave you this one? H equals 1 over 3x minus 5 squared. Can you think of how that would be separated into two basic functions? I'll give you a hint. They usually break down to the library of functions, the basic functions. You see any of the basic functions there? Which one? Okay, we'll put that 3x minus 5. And what's the other one? No, it's just inside there. It's the basic function. One over what? You're close. You're very close. No, because this is g of x. I'm saying that's g of x. So if, in other words, if I just took this out and replace this with an x, what do I have? Squared. There's that squared. Remember, both of these are from our library of functions. This is a linear equation. This is 1 over x squared. Same thing here in this one. Linear, quadratic. Hint, hint. Remember I told you memorize that table of functions? This is where it starts being needed. Let's do another one. H of x is equal to cube root of 2x squared minus 1. Give me two functions that break that one down. Sorry, everybody. It switched over to the main speakers. Oh, well. So everybody figure it out? Let's make g of x the innermost, the basic function. What's the basic function? It's a quadratic equation. So what is the outer function? cube root of x. Because as long as we can figure out a way to combine those, the combination of this one would be f of g. Because I'm putting this one inside that one to get that. So it's f of g of x. So as long as you can break them up, and then you can tell me what it breaks down into. All it's asking for are two basic ones. Okay, we'll do it to get the homework assignments, do the next ones. All right, so that's it for section 2.4. Or 2.3. That one, decomposition and composition. Section 2.4 has to do with symmetry. What does symmetry mean? Yeah. A mirror reflection. Because we're going to use the word reflect a lot. Let me look at two graphs here. That one and that one. Are they both functions? Oh. Remember how you test if it's a function? The vertical line test. This one's a function, but this one's not. So be very careful about that. This is a quadratic equation, y equals x squared. This one is x equals y squared. Here's the y-axis. Here's the x-axis. The y-axis, the x-axis. This one, because you look at the right-hand side, it's mirrored by the left-hand side. We say it's symmetric with respect to the y-axis. For shortcut, instead of writing with respect to, we just use WRT. How about this one? This one is symmetric. WRT, which axis? The x-axis. Because you notice how this thing looks like a mirror. If you took the graph, how would you fold it to make the top equal to the bottom? You'd fold it on the x-axis. This one, you'd fold it on the y-axis. So let's look at these two, and how would we know if it's symmetric about the x-axis or the y-axis? If it's symmetric about the y-axis, if we change x to negative x and get the same y. whenever you get the same, we say these are equivalent equations. So to be symmetric about the y-axis, if we put x or negative x in there, we get the same y, then it's symmetric about the y-axis. Let's look at this. If we put 2 inside there, what's y going to equal? 2 squared is 4. If we put negative 2 inside there, negative 2 squared is what? 4. So we changed x from positive to negative, but we got the same y's. That's how you can tell it's symmetric about the x-axis. I mean the y-axis. The next one we're going to talk about is symmetric about the x-axis. If we change y to negative y and get the same x, then it's symmetric about the x-axis. X equals y squared. So x equals, if I put 2 inside there, 2 squared is 4. And if I put negative 2 inside there, I also get 4. So let's look at these from a point standpoint. I changed from 2 to negative 2. I got the same y values. And if the x values are the same and the y values are different signs, then it's symmetric about the x-axis. Make sense? We're going to work on some examples. There's another symmetry. What if we change both x and y? What's that symmetric to? Symmetric with respect to the origin. All right, so that's what you have to look for there. If x and y's both change, then it's symmetric about the origin. That's example. Let's look at this example. So I want to try the point 2, 2, and then I want to see if it gives me the same answer if I put -2, -2 in there? So I have 2 squared plus 2 squared It should be 8. Two squared is 4 plus 4 is 8. And likewise, -2 squared plus -2 squared equals 8. So it's again, it's gonna be 4 plus 4, 8 equals 8. So what that means is I got an equal point on the other side of the origin. Exactly. Well, what does this graph look like? Chapter 1 already forgotten? Yes, it's a circle. X squared plus y squared, where's the center? Center's at 0, 0. The radius is the square root of 8, which is 2 squared. We did that earlier. You have to remember your formulas. All right, so those are, there's an example. Let's look at a couple examples before we jump in the computer. Y equals x squared plus 3. Tell me what, if anything, it's symmetric to. Let's test if it's x-axis. How do you test if it's symmetric about the x-axis? Change y to -y. So this is our original equation. So I change y to -y. How do we get y by itself? What do I have to get rid of? The negative sign. So we have to change all of their signs. So y equals -x squared minus 3. Do these look the same? Nope. So not symmetric about the x-axis. How about the y-axis? Here we change x to -x. So I change x to -x. So what is negative x squared? It's just negative x, or x squared. It doesn't matter if the number inside there is positive or negative. When you square it, it becomes positive. So the square gets rid of the negative. Notice these are both the same. So it is symmetric about the y-axis. Is this symmetric about the origin? How do we test symmetry about the origin? Well, you have to change x to negative x and y to negative y. You have to change both signs. No, it was x squared plus 3, I'm sorry. Y equals x squared plus 3. So if I change y to negative y, x to negative x, negative x squared, you can get rid of the negative, but the y out in front changes everybody's sign. So is it symmetric about the origin? No. With odd even functions, we describe two conditions of them. Are they odd or are they even functions? It's even if you change x with negative x and you get the same equation. It's odd if you change x with negative x and you get the opposite function. This is what it means. F of x is the same thing. If you put negative x in there, it'll become the same thing you started off with. An odd function, if I put a negative x inside there, then it becomes an opposite function. It becomes an opposite function. Well, it's going to be negative. So, yeah. So, let me give you an example. we had this. If I change x to negative x, x to negative x, so I change x to negative x. Negative x cubed is the same thing as negative x cubed. Minus minus becomes a plus. If I factor out a negative sign, I take out a negative sign, you see here's the original function, there's a negative out in front. That's an example of an odd function.
So at what level are you going to change?
What's that?
At what level are you going to, at what step are you going to change to second and third step?
Well, the first thing you do is change x to negative x. And after you finish simplifying everything, if you can factor out a negative and you get this inside the parentheses is the same as what you start off with, then it's an odd function. That's not actually works. Let me show you the shortcut to all of this. That's too much work there. Let me show you a shortcut. So if I have negative x to the squared, negative x to the fourth, or negative x to the sixth. Let's say I have those three functions. What is negative x squared? What does that come out to be? Positive, so this is x squared. Negative x to the fourth, x to the fourth. Negative x to the sixth becomes x to the sixth. So notice the exponents. If the exponents are even, they cancel out the negatives. How about negative x to the cubed, negative x to the fifth, negative x to the seventh? They're going to stay negative. So it'll be negative x cubed without the parentheses, right? Let's see why. Okay, that's I know what you're getting to. Why is it without the parentheses? Let's do the short one first. So it's negative x times negative x times negative x. They're all multiplied, right? That's the third power. Negative times negative is what? Positive times negative is negative. X times x times x, x cubed. So that's a come, I put the negative out in front. I can just take them out. That's what this becomes. This actually becomes a negative y. So if I start off with this, now I ended up to this. Because if y equals this, if there's negative in front, then that's what I have. So I change from y to negative y. Yeah, yes, that's what it means. I'm sorry. Very good point. So if I start off at y and I end up at negative y, then it's an odd function. Okay, so if you have even exponents, only even exponents, then you have an even function. If you have only odd functions, then you have an odd function. There it is. It changes it from positive to negative. But the question comes, what about constant numbers? Okay, again, if you have even exponents, only even exponents. I just did here. If this was one big problem. But yeah, let me first talk about the constant. Is this function odd or even?
Oh, no. Okay. Oh, we gonna add the lifetime.
There are no like terms.
Well, not lifetime. X squared.
Nope, you don't add those. So to test if it's odd or even, change x to negative x. Negative x to the fourth is x to the fourth. Negative x squared is simply x squared. And plus 3. Are these two equal? So these are even functions. That's an even function. How about this one? Is it odd or even? Or would you venture to guess? That is what would you think first, right? Well, let's try it. I mean, at first you're right. It looks odd, but no. When you do this, you change x to negative x. Again, negative x to the fifth becomes what? Negative x to the fifth. Negative x to the third becomes negative x to the third plus 3. So it's negative x to the fifth minus x to the third plus 3. Are they the same? I mean, are they opposites or the same or what? In other words, to see if they're opposites, if I factor out a negative, because it has to be positive, if I factor out a negative, are they the same? Is this the same as this? When you factor out a negative, you change everybody's sign. Not the same, so it's neither odd nor even. So which is the only function you can have that has constants to be odd or even? Even. If all exponents are even plus a constant, then the function is even. So in other words, if you see a constant number, a plus or minus number by itself, no x's, then only look at the exponents. If they're not all even, if they're all even, then it's even. If they're a mix, it's nothing. Because constant numbers do not work with odd exponents. An odd equation only works if you have odd exponents. Only odd exponents. Then it's an odd function.
So basically, if it has a constant in it, it's not an odd function. It's neither odd.
If it has what?
If it has a function in it, it's neither odd. If it has a constant in it with
Odd exponents.
odd exponents.
Right. Yeah, if it has odd exponents with a constant, it's neither. But if it has odd exponents or even exponents and a constant, or even exponents by themselves, it's even. So a constant can only be with evens to be an even function. So in other words, what an odd function means is we want to change this from a positive to a negative function. So I change all the x's to negative x. So it just becomes a negative value. Positive and negative becomes a negative. Positive and negative becomes a negative. Now, since they all have the same sign, we can factor out the negative sign, which means we change everybody's sign inside there. I took out the negatives. What's inside the parenthesis matches the original equation, but it has a negative in front of it. So it goes from positive to negative y because of that negative in front. Yes, no, kind of. Now, here's a shortcut. Is finding odd or even functions pretty easy? All you have to do is look at the exponents. Two x to the fourth plus 3x squared plus x minus 4. Is that odd, even, or neither? Because you have an odd exponent right there. They either have to be all odd or all even. Odd, even, or neither. Why? Yeah, because it has a constant. Odd, even, or neither? Why? Yeah. If there's nothing on the top, it's 1. So that's odd. That's odd. All the exponents are odd. No constant. It's odd function. Odd, even, or neither? Yeah. All the exponents are even, and you have a constant, so it's even. Now, so determining whether it's odd or even only matters, look at the exponents. That's much easier than, remember we talked about symmetry, about the x-axis, y-axis origin. If a function is odd, it's symmetric about the origin. If it's even, it's symmetric about the y-axis. That makes life a lot easier for us. Makes life a lot easier to determine whether it's odd or even, is symmetric about the x-axis, the y-axis or the origin. The only thing we have to worry about is symmetry about the x-axis. So this, hopefully, just looking at the equation, you can tell me if it's odd or even. And that tells you if it's symmetric about the origin or y-axis. No work involved. So the only work you have to do is for the symmetry about the x-axis. All right, let's take a break and come back and we'll start doing homework problems.